Onto wood products now. So what kind of new technologies are being developed or do you think would be needed in the wood processing and products sector?
I don't know about processing so much. I mean, I think there's a lot of development in this whole methodology it's used for grading, but I'm not really the person to, I'm not the world's expert on grading. I think you need to talk to Dan Ridley-Ellis at Napier about that. But I know that the simple technologies of just bending a piece of wood and then using that property to infer other properties are becoming less used, and they're using X-ray techniques and they're using machine learning techniques, and there's all kinds of new developments coming in where they can get a whole bunch of different measurements and work out much more accurately what the property is that you're interested in, such as strength. So that's certainly one of the areas where we're getting a lot of development. There's been a lot of publicity around the sort of cellulosic composites. I suspect maybe a little bit too much publicity around it, but I mean, there's certainly a lot of interest in this area. Invariably, the headlines are accompanied by stronger than steel, but I think we've just discussed the specific properties already are stronger than steel. So that's not necessarily an improvement, but it seems to be a way of getting a headline. But I think there is interesting developments there. Quite what we're going to see coming out of that, I'm not sure at the moment, but there certainly are things appearing. From my personal perspective, I think one of the potentially most interesting areas is probably this ability of wood to deform in different environments through relative humidity, and I wonder if there's more that can be exploited by having elements where we put oriented wood samples together, glued together, which will then behave in a certain way when the moisture content changes, something like that. But then we have all the obvious things, like we have the composite materials, the glulams, the stress lam. And yes, stress lam's an interesting technology. So there's a whole bunch of laminated wood products, and I think they're going to get much more important as we use the resource in a more efficient way, because obviously we can use more of the wood as a consequence. So.
Yeah, I think
anything that you can add to?
Well, just kind of thinking and reflecting a little bit on the kind of research that we're involved in, also looking at the kind of the what can one do with wood that has already been through one life? How do we reprocess that? That's something. And I mean, a lot of our wood products are glued. And I mean, that's one of the big at least perceived downsides, but also real downsides in terms of kind of environmental credentials of wood is the glues that we use. So I mean, can we develop new adhesives that are less impactful, or find other ways of joining wood? Mechanically joining.
I mentioned stress lam.
So whether those kinds of things would come up in the future.
I used to do this a lot. If you look at it's like Japanese, I know we're getting off a bit, Japanese buildings and the way they hold those bits of wood together, no adhesive at all. It's these really clever joints and that sort of thing.
It amazes me that we have so much good kind of technology now around CNC milling and stuff like that, that we can create these joints very, very quickly and very, very accurately. So why don't we actually use them a little bit more? I think that might be something.
Point. I mean, a lot of these joints, they're beautiful, but they take a lot of time, and therefore they're expensive. But like you say, if you've got CNC machining, you can use these just like any other. But they are so clever, some of these joints.
But I guess we're always going to need some kind of a glued systems. I mean, to utilise those parts of the material that can't be used in solid wood form. I mean, particle board is a useful material for many kinds of applications. So, but are there alternatives that would actually replace the formaldehyde-based adhesives that we currently have? I mean, I've heard of different developments over the years, but there's not so much that's actually out there in the commercial world, to my knowledge at least.
Yeah, I mean, there have been developments in the past, and I've no doubt, you know, we might see those reinvented or coming in, but a lot of them failed simply because of economics. But of course, as soon as oil price goes up, everything changes. So a lot of these adhesives that get used simply because they're cheaper. But if oil price goes up, it changes the equation.
Whole dynamics. Okay, so I mean, just following on for that, how do you see the product development processes for novel wood products going in the future?
Is that the same question?
I mean,
subtly different.
Subtly different, products.
If I could predict the future, I wouldn't be sat here talking to you. I'd be sitting on a yacht in the Mediterranean. If I could predict the future, how do I see these developments going? Well, I think, as we've already discussed, I mean, certainly the composite area is going to see further developments for sure. I'd be very interested to see how the microfibril research does develop. A lot of money's been put into it, and we are starting to see things coming out of that.
Yeah.
But I really honestly think that the main innovations are going to come about, as we discussed a lot earlier, not so much with the timber technology, but the way that we design things out of timber and how we design for repurposing and design for reuse and design for disassembly. That's where I think
that's actually quite an interesting kind of a mindset shift, in the sense that I know you've been involved a lot over the years in for example, modification of wood.
Yeah, so I figure that might be why that question was in there. But I've been avoiding it.
But I'm just thinking that it's actually a bit of a mindset shift, thinking, going back to the original design, rather than trying to design and modify the material for a particular application, go back to the original design. But maybe what are your thoughts on kind of modification of wood? And is there, do you see a future in that?
Oh, absolutely. I mean, I think what we need to bear in mind, although modification is getting bigger all the time, it's still quite a small proportion of the total timber that gets used, and it isn't always necessary to have modified wood in particularly structural applications, providing those structures are well protected from water, especially water ingress. But in areas where we do have exposure, exterior exposure, then I will expect there to be continuing developments, particularly in resin impregnated wood. The real holy grail, in my view, is if we can ever get this wood weathering. You know, a lot of pictures you see that architects put up at their buildings are just after the building's been made, not after it's weathered. An architect knows what they're doing, will make sure it weathers evenly, but far too often we see the overshadowing effects and this sort of thing. So I think if we could develop a technology that prevented wood weathering, that would be quite amazing.
Or we just learn to accept it.
Or we accept it. If we accept it, then we design so that we get even weathering, which is not impossible.
No.
Not impossible.
No. Just maybe I'm going to follow on with another question on the modification front. I mean, to my kind of understanding, that most modifications do result in property improvements, but also property losses. For example, thermal modification usually embrittles the material, which really prevents it being used in any kind of structural application. What about other modification techniques? Do they have similar effects? You mentioned resin impregnation. Does that adversely affect properties in the same way?
I've not come across a modification that doesn't lead to wood becoming more brittle, but isn't necessarily the issue. The issue is we have with wood in standard applications, structural applications, we have design rules which are based on a lot of tests, and we don't have those sort of tests behind modified wood backing up design rules. So although brittleness could be an issue, it isn't necessarily the problem, because if you work within design limits, you'll never encounter that behaviour. But of course, we don't have the data to support the design rules. That's the problem.
It's kind of a little bit ironic that I mean, many of the problems that we are trying to eliminate with the modification are due to the moisture, and it's actually the moisture that gives the wood its properties in the first place. But
it gives you good properties like toughness, but it gives you properties that aren't so useful, such as creep. And you can't separate the two.
No. What would help in getting new wood products to the market?
Money.
Okay. Would you like to elaborate any more on that?
Lots of money.
Lots of money.
I mean, quite honestly, I've been involved in this area for a very long time, and I've seen various technologies look promising and then not get all the way, which is quite sad in many cases, because they're perfectly good technologies, and what runs out is always the money. It takes a long time to get a technology to market. I've talked to people that thought they could do it in 6 months. 10 years is typical. So in that 10 years, you are going to be losing money. You probably won't make money for another 5 years whilst you're establishing yourself. So that's the problem. That's the barrier. It's purely financial. Once you get there, you're okay, but you've got to be there for the long haul. It's not a quick. You don't make a lot of money very quickly. So it's quite a simple answer, actually.
Yeah. I mean, is it usually due to kind of consumer acceptance, or is it due to the technology development that's required, or is there?
No, none of that.
No.
Sometimes people work with pieces like this, and they go, "Yay, we've got a new technology," and then you start trying to impregnate.
Something like that. Okay. So it's to do with scaling.
It doesn't behave the same because, of course, the permeability of this is probably what's come from the sapwood. But are we dealing with heartwood, sapwood? Very
Yeah.
often with a
Yeah.
impregnation, we have to work with sapwood only,
So,
which means what we're going to do with the heartwood, and that it changes the economics.
Yeah.
So
yeah.
you just have to be aware. The trouble is, like, you tend to get chemists come along,
Yeah.
think they know everything, so as a chemist,
Mm.
and they don't understand the wood, or you get timber technologists come along and don't understand the chemistry.
Yeah.
And actually, we need both these sorts of people to develop these technologies.
I think that's an important point. We need at least in wood in general, the use of wood, we need much more multidisciplinary.
it's very
we need designers and architects and
absolutely.
chemists and engineers all
Yeah.
working together around how to use this.
That's why it's such an exciting
Yeah,
subject area,
exactly.
because
Yeah, yeah,
the people you meet and the
Yeah.
subjects you have to learn about.
yeah.
It's
Exactly.